So at the front of our model, we have the parental DNA, which is the DNA that the offspring will receive from the parent, which is the original DNA. And then next up, with that big purple ring, is the topoisomerase, which is an enzyme that breaks, swivels, and rejoins the parental DNA ahead of the replication fork, relieving the strain caused by unwinding of the DNA molecule.
Next up, we've got helicase shown in the purple. This is what causes the replication fork in the DNA. It basically splits the hydrogen bonds between the bases and allows for them to both go off as single strands.
And then those light green bumps will be the single-stranded binding proteins. And the role of these is to stabilize the separated parental DNA strands and keep them from repairing.
And then next in the pink, we've got primase, which basically adds a primer, as you can see in like the lagging strand, but also there's some in the leading strand. But basically, primase puts a primer onto like the areas where bases will be made out of RNA, so that the DNA polymerase can later go on and basically connect the bases with newer ones.
And then next up is the leading strand. That is going to be the light blue strand you see. And this strand is going to be one long line of a strand. That's how it forms, and then it goes in the direction of helicase as opposed to the lagging strand. And then DNA polymerase 3 is at the front of this, which is pretty much the proofreading factor of the strand, making sure everything is all right.
Yeah, DNA polymerase 3 can like proofread and then also attach bases. Basically, it does everything. But in the lagging strand, it goes the opposite of the leading strand from 5 to 3 prime. And in the lagging strand, because of its direction, we get Okazaki fragments, which are little fragments of bases that aren't really connected. And so we've got to have DNA polymerase 1 run over that to make sure those are correct. And then for those to connect, we get DNA ligase. And so those Okazaki fragments then connect because of the DNA ligase.